Hi, I'm Firus, and in this video, I will talk about acid-base neutralization, one of the topic in Chapter 4, Aqueous Solution. These are the learning objectives for this topic. At the end of this lesson, you should be able to write a balanced chemical equation for neutralization reactions. Second, you need to be able to calculate concentration using titration formula. And lastly, you need to be able to sketch titration curve. What is an acid-base neutralization? It is a reaction in which when an acid and a base react to produce a salt and water in an aqueous solution. For the reaction between acid and base, it will produce salt and water. As it is shown in this equation here, we have hydrochloric acid, it is an acid, react with sodium hydroxide, and then it produces NaCl, and NaCl is a salt, while H2O is water. The salt that is produced is made up of a cation from a base and an anion from an acid. For example, here the salt produced is sodium chloride. So this sodium chloride is made of the cation from basic solution, which is the sodium ion, combined with the anion from the acid. So this is the acid, the anion is chloride ion. So when chloride combined with Na, it will produce the salt of sodium chloride, while the water is the product from hydroxide from the base solution and hydrogen ion from the acid solution. This process, neutralization, is a double replacement reaction because we replace the cation and anion between the acid and base solution. Here's another example. We have nitric acid react with a basic solution of sodium hydroxide ion. So for the production of the product, we have salt and water. So the salt is made of the cation from basic solution, which is sodium, and the anion from the acid solution, which is nitrate. So sodium react with nitrate, it will produce sodium nitrate. And then the water is from the hydroxide of basic solution and hydrogen ion from acid solution. In the acid-base equation, it is important for you to make sure that the equation is balanced. When you want to write the formula for the salt that is produced, you need to make sure you have the charge of the cation and anion correctly. For example, this one, when we have sodium that has a positive 1 charge, react with nitrate that has a negative 1 charge, so it will produce NaNO3. So how to write a balanced acid-base equation? Let's look on the first example here. We have nitric acid react with magnesium hydroxide. So first, you write the equation magnesium hydroxide react with nitric acid. And then the next step, you find what is the salt that is produced. So the salt produced is between the cation of the basic solution, magnesium, and anion from the acid. So it will be magnesium nitrate. Before you write the chemical formula of the salt, you need to know what is the charge of the cation and anion. So magnesium has a positive 2 charge, while nitrate has a negative 1 charge. And because of that, when we bring the charge to the opposite side for the subscript, so it is written as magnesium nitrate 2. So the 2 charge from the magnesium will be bring to the opposite side to the nitrate and become the subscript of nitrate. And then the other product is water. After that, you balance the equation. Since we have 2 nitrate, okay, so we need to put 2 nitric acid, and now we have 2 hydrogen, so we need to add 2 at the front of the chemical formula of water. So now this equation is balanced. Next, we go to the second example. It is between sulfuric acid and potassium hydroxide. So identify the salt that will be produced first. So it will be potassium ion react with sulfate ion. So it will produce potassium sulfate. Potassium, the charge is positive 1, while sulfate has a charge of negative 2. So when we write the chemical formula, it will be K2SO4. And then the next product is water. And then you need to balance it. So we have 2 potassium here. So we need to put 2 in front of KOH. And then hydrogen, we need to balance since the left side here we have 4 hydrogen. So we need to add 2 here. And then the equation is now balanced. Next, you can try this exercise. Write the balance equation for the following acid-base reaction. Number 1, it is between aluminum hydroxide and hydrochloric acid. And number 2, it is between phosphoric acid and calcium hydroxide. Next, we will proceed with titration. What is titration? It is a laboratory technique used in chemistry to determine the unknown concentration of a solution. We call it as analyte by reacting it with a solution of known concentration. The known concentration, we call it as a titrant. Basically, in titration, you need to have 2 solutions. One solution is unknown concentration, and another one, you need to have a known concentration of solution. Okay, for example, you want to determine the vitamin C in fruit juices. So the fruit juices would be your sample, and the vitamin C concentration would be the unknown that you want to determine what is the concentration. So the fruit juices, we will put it in one of the 2 apparatus that we need to have in a titration procedure, which is we need to have a burette and conical flask. So the fruit juices, we will put it in the conical flask. You need to put a certain amount. For example, we put 25 ml of the fruit juices. Okay, and then you need to have a basic solution. Since fruit juice, it is acidic solution, so you need the opposite type of solution to be the titrant. So we need to have a basic solution. For example, you can use sodium hydroxide. So sodium hydroxide, you need to know what is the concentration. And then we put the sodium hydroxide with a known concentration inside the burette. So that will be the titrant. The solution that is placed in the burette is called as a titrant. And then you perform the titration. I will explain in the next slide how the titration is performed. In the titration, a solution of accurately known concentration is added gradually to another solution of unknown concentration until the chemical reaction between the 2 solutions is complete. So as I said just now, let's say we want to analyze vitamin C in fruit juices. So we put the unknown concentration of vitamin C that is in the sample, the fruit juice, we put it in the conical flask. Let's say we put 25 ml. And then before we start with the titration, we need to put an indicator inside the conical flask. What is an indicator? It is a substance that changes color at or near the equivalence point, which means when there is color change, you need to stop doing the titration. Usually we need 2 or 3 drops of indicator, place it in the solution in the conical flask, and then you start doing the titration. After you put the titrant inside the burette, you need to record the initial volume before the titration begins. And then you slowly add the basic solution to the unknown fruit juices until the indicator changes color. For example here, when a solution is in acidic form, when we put an indicator of phenolphthalein, the color would be colorless. When we add basic solution slowly, after it reaches a certain point, it will change color to pink. When the color changes to pink, means the reaction is complete. This is what we call as equivalence point, the point at which the reaction is complete. When the color has changed, you need to stop the titration and then record the final volume of the burette. So that will be the volume of titrant used in the reaction. Next, what you need to do is you calculate what is the concentration of the analyte inside the unknown sample. To calculate the concentration by the titration method, we need to use this formula MAVA over MBVB equal to A over B. Let's say we have a titration equation such as in this example. So A is acid, B is base, C is salt, D is water, for example. So in the balance equation, there will be coefficient. From a balanced chemical equation, you can know what is the value for the coefficient. The coefficient represents by the A, B, C, and D here. For the formula of the titration, Ma is the molarity of acid, Va is volume of acid, Mb is the molarity of base, Vb is the volume of base solution. A is the coefficient of acid from the balanced chemical equation, and B is the coefficient of base solution from the balanced chemical equation. Let's look at this example. A student titrated 25 cm³ of hydrochloric acid with sodium hydroxide of concentration 0.1 molar. It took 30 cm³ of sodium hydroxide to neutralize the acid completely. Calculate the concentration of the hydrochloric acid. First step that you need to do is to identify the information from the equation. From the equation, we know that the volume of acid is 25 cm³, while the volume of sodium hydroxide, the basic solution, is 30 cm³. And then the question also gives you the concentration of sodium hydroxide, which is 0.1 molar. So that would be Mb. The question is asking for concentration of acid. So we are looking for Ma. After you take out all the information given, you need to write the balanced chemical equation between the acid and base solution. So we have HCl react with NaOH. So this would be the equation, a balanced one. The next step, you use the titration formula. You substitute the given information. And then for the coefficient here, since we have 1 over 1, so that's why 1 over 1. And then you use your calculator, and then you will get the value for the molarity of acid is 0.12 molar. So that's how you use the titration formula. Next, I want you to try this exercise, calculation involving the titration formula. You can try to answer these two questions and another two questions.